guidelines of earthquake resistant masonry structures. So, because we actually don't have a subject as earthquake in our UG level, and at MTech level we have a level of earthquake resistant design of structures. I don't know how many of you have studied that. Alright. So I'll start with very basic things. Okay. And as we proceed, we'll discuss different things. What are earthquakes? Where they do occur? Very simple. You might have studied at your UG classes in geology. Alright. Faults along the plate boundaries. Majority of earthquakes occur along plate boundaries, and therefore they are called as interplate earthquakes. There can be different earthquakes generated by different volcanic eruptions and filling of reservoirs, and all these kind of things. But major earthquakes which we are concerned about in design occur along plate. So what is an earthquake? Fault rupture, and large energy is released. Alright, and there are different type of waves which are called as body waves and surface waves. Of course, just an idea. We are not going to discuss all this seismology above. Alright. Earthquake, body waves, surface waves. Alright, you have a structure up there, and these surface waves, these are waves, they are motion. So how is the force generated? Force is nothing but mass into acceleration. Mass of foundation, if is large, earthquake forces attracted will be large. So F is equal to M. That's you know that. Next, so soil plays a very important role. Soil plays an important role in terms of there are different type of waves. Alright, and these waves can be long period waves and short period waves. So amplification of forces and the movement and the wave transmission, these play a very important role, and soil properties are very, important. So we have to investigate the soil properties. And what is an earthquake? Earthquake can be defined as random, cyclic, transient motion. Random, cyclic, transient motion. Okay, transient for a very short duration. And if we talk in terms of energy release, so it is nothing but release of energy, elastic energy stored in the rocks. Alright, so you can see here, there is a fault there which is called as San Andreas fault in the very first picture. And how this earthquake is generated, and there is a movement along the fault, and how these plate boundaries are deforming, and elastic energy, and once the energy is erupts out, it is stored energy, it releases. Alright, then last figure you can see the deformations do vanish, but there is a permanent, what you call as movement, which will be there. So elastic deformation, because any change in shape or size, it disappears when the deforming forces are removed. So that is it. So we can define as sudden release of elastic energy stored inside the rocks. Yes. So just to show you how these earthquake forces or waves which are generated, two types of waves, surface waves and body waves. So surface waves and body waves are divided into different. We are not going into detail of those, but what happens to a structure, that is what is important. That you can see here, P wave travels first, P wave attacks, that is your structure under observation. Alright, so what happens in a P wave? It is nothing, you can say compression and elongation type of wave. Next, then S waves come, they damage the structure. Next, surface waves considerable damage. Alright, so we have to minimize the damage. Okay, there will be earthquakes, and IC 1893 has divided earthquakes into major earthquakes and design-based earthquakes. Alright, whose return period is different. So let us not go into the detail of those. But when all the waves travel, which I have shown you earlier, this will be the fate of the structure. So what should be done to minimize ultimate fate? What happens is a structure comprises of structural elements, non-structural elements. All right. So you can't make a structure earthquake proof. You can make it earthquake resistant. Okay. All right. So that's what we are aiming to. It can be a masonry structure. It can be a earthen building. It can be a stone masonry structure. It can be a brick masonry structure. It can be a RC building. So how to make them earthquake resistant? That is what is important. So okay. Intensity, again, you have magnitude, which is based on energy release. I'm just giving you the preliminary talk before I come to codal provisions. Alright. So what is what? Magnitude is an earthquake released, energy released. Richter scale gives you an idea, and then again there are many ways in which we can measure magnitude. Let's not go into the detail of those. Alright. So it depends on the size of the fault that breaks. That is what is important. Energy released is another important thing, and intensity is it just depends upon the distance from the earthquake and strength of earthquake. All right, distance from the earthquake means distance from where the earthquake focus is there, which I had shown you earlier. All right, so intensity of shaking and damage at specific location, that is given by MMI, Mercalli intensity scale. Damage assessment, and which depends on earthquake, the structure's distance from the earthquake. All right, and what is the strength of earthquake, and magnitude is the energy released. All right. But just to give you an idea of this is the magnitude, different magnitudes. All right. And there is movement every time. There is a movement which is taking place right now, but that can along the fronts, but that cannot be felt. Okay, so what are minor, major earthquakes? They depend upon the magnitude. All right, so major, great earthquake is somewhere around 9. Smaller earthquakes, moderate, and most of the earthquakes which have got 6 to 7 scales. All right, and what I want to show you here is 6 to 7 energy released is equal to what exploded in Hiroshima, an atomic bomb explosion in Hiroshima. All right, and that is equal to the energy released when you actually explode an equivalent kilograms of explosives. This is it. 56 into 10 to the power 6 is the equivalent kilograms of explosive. All right. When it explodes, this much energy will be released, which is equal to how much earthquake between 6 and 7. Okay, that's an idea. Okay, next. These are the provisions of different codes. Okay, these are codes which have been revised. I'll give you information on that. All right, and these are the different earthquakes. Okay, earthquake for design of buildings, ductile detailing code. All right, 43226. Again, earthquake resistant design for structures, and these 3A828, 827, 935 are codes on earthquake resistant earthen buildings, earthquake resistant stone masonry buildings and earthquake resistant masonry buildings. So these are the different codes, but they have 3 have been revised, 2 have been revised. So recent revision of the codes is 893 2016 part 1, 13920 2016, all right, and 43263. 3 of these codes have been revised. Because why revision takes place, you know, as new researches, all right, new materials, research on new materials, all right, and previous experience of past, how the structures behave in the past earthquakes, that gives us a lesson, okay, and through those lessons and through the development which has occurred in this timing, in this time, during this time, based on all those, we design, we revise. So this is the revision, and next, let us come to now masonry. Masonry, it is masonry when we are using, it can be any masonry, stone masonry, all right, it can be brick masonry, and it can be an infill in a RC frame structure. Infill in a RC frame structure, it actually, that is the first line of defense when an earthquake strikes and it's an RC frame structure with infills. Of course, with infills, what will happen is, what will be the first line of energy which the structure will dissipate energy when it vibrates during earthquakes. Is it not? So the walls, they will be the first line of defense. All right, I'll show you a slide later, and how much energy those walls take up. That is maximum as compared to any other structural component of the structure. Okay, so brick, stone, concrete blocks. That is what it can be with mortar. All right. Okay. So mortar will be different. Of course, we are not going to take cement mortar in stone masonry buildings. All right. Stone masonry buildings, the stones may be dressed or undressed. All right. So improvement can be when you are applying. If you are going for, better material. All right. Better material means we know that undressed stone and dressed stone will be better in a stone masonry. So mortar varies. It can be just mud mortar. It can be lime mortar. It can be cement sand mortar. All right. What is important is it has got low tensile strength, and they are just carrying what are called as vertical loads. And